Swayam Prabha. Digital India. Educated India.
Welcome back to the course Geology and Soil Mechanics. So, in the last lecture we have solved a couple of problems on the compaction of soil, and today we will be taking one more problem, and the problem says that a compacted field is to be constructed using one of the two potential borrow areas A and B. Okay. So, I mean borrow areas means from where you can collect the soil to construct the embankment. So, the in situ properties of soil at these sites are as follows. The borrow area A gives the E natural, that is the natural void ratio is equal to 0.8, water content, that is W natural, is 17.5%, and GA is, that is the specific gravity of soil solids, equal to 2.65, where the borrow area B gives E natural equal to 0.68, W natural, that is small w natural, what is that is your water content is 14%, and GS, that is the specific gravity of soil solid, is equal to 2.65. Now, the compacted volume of the embankment will be 50,000 cubic meter. Its unit weight 20 kilonewton per cubic meter at a placement water content of 20%. So, this is the requirement for the embankment which is to be constructed. Now, soil from the borrow area is to be excavated and transported to the site in trucks of 10 cubic meter capacity. During the excavation and dumping of soil in the trucks, the soil increases in volume by 10%. So, that kind of allowance you have to consider. At the site, the required additional amount of water is added to the soil and compacted to the desired extent by pneumatic rubber tired rollers. The cost of excavation, transportation and compaction is rupees 400 per truck for borrow area A and rupees 500 per truck for borrow area B. Water charges per truck is rupees 150. Which of the two borrow areas is more economical? So, this problem is basically the based on some practical situation. That means you want to construct one embankment, and that embankment construction will take the soil or will borrow the soil from different locations or different sites. Now, you have to find out, as an engineer, you have to find out which borrow area or which location will be economical for construction of this embankment. So, now let us start this problem. So, this problem is saying or is elaborating all the parameters. Now, based on those parameters, you have to find out which one will be the economical. That means, which one will give you the less amount of cost to construct the embankment. So, let us solve this problem. Now, first we will write down what are the different properties available for the embankment. So, for embankment, you know the bulk unit weight is given, that is 20 kilonewton per meter cube, that is cubic meter. The volume of the embankment or the soil of which is coming on the embankment is 50,000 cubic meter, and the water content is 20%. Okay. So, these are the things are given for the embankment construction. So, the embankment, after construction of the embankment or whatever embankment you are considering, so that basically takes those parameters, that is the bulk unit weight is 20 kilonewton per meter cube, the total volume of soil is 50,000 cubic meter, whereas the water content is 20%. Okay. So, now we will find out the weight of soil. So, when I am talking about the weight of soil, that means this is taking care of weight of soil solid plus water. That means this is the weight of moist soil. So, weight of soil, how can I get the weight of soil? That means the gamma bulk, that is the bulk unit weight multiplied by V, simple. So, the volume multiplied by the unit weight will give you the weight of soil. So, that is giving me 10 to the power 6 kilonewton. Okay. So, that is the weight of total moist soil required for the embankment construction. Now, you can find out weight of solids. How can you find out weight of solids? So, now this is the weight of soil. Now, if you find out weight of solid, if you can manage to find out weight of solids, then you can find out how much water, that is the weight of water, is present in the embankment soil. Okay. So, weight of solids is nothing but capital W, that is the weight of total soil or the moist soil, divided by 1 plus small w, that is the water content. Okay. So, this is the expression. So, if you put the values here, 10 to the power 6 by 1 plus 0.2, which will be giving me 8.33 into 10 to the power 5 kilonewton. Okay. So, this is the weight of solids, which will be remaining constant whatever you do. I mean, if you collect soil from bore area A or if you collect from bore area B, the weight of soil solids will be remaining constant, right. So, weight of the volume may change, right. The volume will be changing, the total volume will be changing, or whatever you are collecting based on the void ratio, volume will be changing, but weight of solids, it will be remaining same. This much of weight of solids is required to construct the embankment. That is all. So, therefore, weight of water, which will come as 10 to the power 6, that is the total weight of the solid, that is the moist weight of the soil, minus the weight of soil solid, which will give me the value 1.67 into 10 to the power 5 kilonewton. So, this much of water is required to compact the soil to construct the embankment. Okay. Now, coming to the volume of solids. How can I get volume of solids? I know weight of solids divided by specific gravity into gamma W. So, I am considering gamma W is 9.8 kilonewton per meter cube. Okay. So, this is the consideration for this problem. You can consider gamma W equal to 10 or 9.8, that does not matter. But anyway, for this problem I am considering gamma W equal to 9.8. Okay. So, which will give me 32,075 meter cube. Okay. So, this much of volume of solid is required to construct the embankment. So, no matter whatever bore area you are considering, this much of volume of solids you must bring, okay, from the respective bore area. That is all. Now, if you try to plot the three-phase diagram, or rather yes, the phase diagram for this embankment soil, then it will look like this. So, let us draw that. This is your air, this is your water, this is your soil solid. This side you have the weight axis. So, total weight of the moist soil was how much? 10 to the power 6. Where you have the separation for the water as well as for the soil solid. For water it came 1.67 into 10 to the power 5. So, all are in kilonewton, okay, and this is coming as 10 to the power 5. So, kilonewton, let us write down that. Okay. So, this is the phase diagram as air is not having any weight. Okay. So, this is the weight axis. Now, if you plot that thing for the volume, so this is 32,075 meter cube. So, that is the volume of solids, it has come like that. Now, the total volume which will include the volume of air now, so that already has been given in the problem, that is 50,000 meter cube. So, this is the phase diagram. So, you can find out the volume of water also from this with these values, because you know the weight of water. So, from this you can find out the volume of water. So, that is not a problem. So, this is your phase diagram for the embankment soil. Now, let us talk about, or let us analyze the different borrow area. Like first we will consider borrow area A. So, first we consider borrow area A. So, what is the natural void ratio in borrow area A? E natural is given as 0.8. So, volume of soil needed to have cubic meter of solids. So, as I told you that the volume of solids will be remaining same, or it will remain unchanged for whatever borrow area you consider, right. So, your volume of soil needed to have this volume of solids will be 32,075 into 1 plus E natural, that is the E available for that particular borrow area, that is 0.8. As simple as that. Okay. So, that comes around 57,736 cubic meter. So, this is the total volume required to be excavated from borrow area A. Okay. Now, find out the number of track trips required to be made using allowance for 10% increase in volume. So, what does it mean? That means this much of soil basically you have to transport, okay, by using the trucks. Now, when we are talking about number of truck trips, when we are calculating required to be made making or using the allowance for 10% increase in volume, that means basically this much, this is the total volume which needs to be transported through by the truck, plus some 10% increase in volume must be incorporated as given in the problem. So, total volume is required why this 10 is coming into the picture? Because it is given in the problem per truck can carry only 10 cubic meter of soil. Okay. So, this 10 is coming here. So, that gives me 6351 number of trips. Okay. So, you need 6351 number of trips to transport this much of soil which will be having this volume of soil solids which is actually required for the embankment. So, that means you are taking or you are keeping all the allowance and you are transporting this much of volume, this much of total volume, this is the total volume required for the embankment, plus multiplied by some allowance you are considering, and that gives you a total volume which is getting transported by the trucks. So how many number of truck trips you need? 6,351. Okay. Now amount of water present in 57,736 meter cube of soil is equal to small w natural, that is the natural water content at borough area A, multiplied by the weight of solid, right. So that is given in the problem 17.5%, which is nothing but 0.175 into what is the weight of solid? 8.33. Already we have derived that 10 to the power 5. That is not going to change, right? That will be remaining same. So it is coming around 775 kilonewton. So this much weight of water is present in this volume which is getting transported from borough area A. Okay. So now in the embankment, okay, what was the water present in the embankment? So that already you have calculated. So additional amount of water needed is equal to this much is the requirement in the embankment, this much water is present in the soil which you are transporting. So additional amount of water basically you need to transport by using trucks, and you have to mix in the embankment side, and then you have to compact, right. So that comes around 21,225 kilonewton. So this is your additional amount of water which needs to be transported by trucks, okay, and which will be mixed later on to compact the soil in the embankment site. So number of truck loads required to transport water is equal to 21,225 by 10 into 9.8. So this is the total weight, and this is the volume, okay, which will be carried by the truck. So truck capacity is 10 cubic meter multiplied by the unit weight of water, which will give me the weight per truck. So that gives me 217 number of trips. So for borough area A, cost of excavation, transport,